Today we're going to be looking at Section 10.6, Radical Equations and Problem Solving. On example 1, we're asked to solve the following. The square root of 2x minus 3 equals 9. The first step is to square both sides, and we find that 2x minus 3 equals 81. Adding 3 to both sides of the equation, 2x equals 84. And then dividing both sides by 2, we find that x equals 42. On example 2, we're asked to solve the following. The square root of a negative 10x minus 1 plus 3x equals 0. The first step is to move the 3x over to the other side of the equation by subtracting 3x to both sides of the equation. Then we're going to get rid of the radical by squaring both sides of the equation. When we do that, we find that a negative 10x minus 1 equals 9x squared. Then we take the 10x and the minus 1 over to the other side of the equation, and we find that 0 equals 9x squared plus 10x plus 1. That factors quite nicely into 9x plus 1 times x plus 1. Setting each of those pieces equal to 0, we find that x equals a negative 1/9 and that x can equal a negative 1. On example 3, they ask us to solve the cube root of x plus 1 plus 5 equals 3. The first step is to move the 5 over to the other side of the equation by subtracting 5 to both sides. We find that we have the cube root of x plus 1 equals a negative 2. Then we cube both sides of the equation, and when we do that, we get x plus 1 equals a negative 8. Subtracting 1 to both sides, we get x equals a negative 9. On example 4, they ask us to solve the square root of 4 minus x equaling x minus 2. So the first step is to square both sides. And when we do that, we find that we have 4 minus x equals x squared minus 4x plus 4. Combining like terms, we end up with x squared minus 3x equaling 0. We factor an x out of that, and we get x times the quantity x minus 3 equals 0. Well, the x out here, if it were 0, that would work. So that's a solution. And then we set x minus 3 equal to 0, and we find that the other part is x can equal 3. Well, we want to check our answers by plugging them in the original equation. If I put 0 in here, I get the square root of 4 equaling a negative 2. And we know that that does not work. So x equals 0 does not work for a solution to our example 4. On example 5, we have solved the following. The square root of 2x plus 5 plus the square root of 2x equals 3. Subtracting the square root of 2x to both sides, we find that the square root of 2x plus 5 equals 3 minus the square root of 2x. Then we square both sides of the equation, and we find that 2x plus 5 equals 9 minus 6 times the square root of 2x plus 2x. Combining like terms, we find that 6 times the square root of 2x equals 4. And now we square both sides of the equation to get rid of that radical 2x. And we get 36 times 2x. And on the right side, we get 4 squared, which is 16. 36 times 2x is simply 72x equals 16. Dividing both sides of the equation by 72, we find that x equals 16 over 72, When we reduce that by taking 8 into 16, which is 2, and 8 into 72, which is 9, we find our reduced answer for x equals 2/9. Example 6, we're looking at the Pythagorean theorem for right triangles, and it simply states that a squared plus b squared equals c squared, where a and b are the legs of the right triangle, and c is the hypotenuse. So applying that then, we have example 7, find the length of the unknown leg of the triangle. So here's one of the legs, and here's the hypotenuse, but we're trying to find this leg. So we say 8 squared, plus b squared equals 17 squared. Continuing to simplify, we get 64 plus b squared equals 289. Then b squared, if we add 64 to both sides, must be 225. Taking the square root of both sides, we get b equals the square root of 225. And we know the square root of 225 is 15. So our unknown leg is now, we know, 15.